Integral challenge 7. Create a differential equation and integrate it. The problem here is stream. The stream speed is 0 at the edge and increase and becomes 0 at the other edge. It's a quadratic equation. Okay, so stream speed is a coefficient k, and it depends on the location of y from 0 to a. So that gives the symmetric profile of the stream speed. The boat is going from one side to another side at the speed v. So projectile, how do we make a differential equation? That's the key. Once we get the differential equation, then we have to figure out how to integrate it. Okay, stream speed is this, boat speed is v, projectile xy. Now the motion of the boat is a function of t, parameter t, the time factor here, and dx dt is stream. Stream is running this speed, and crossing speed is v. Now we want only dy and dx. We don't want to get into the dx, because if you try to take an integral of this on t, then a lot of problem. Before we take integral, what we do is we want a dy dx. That's give us the profile y equals fx, right? So dy dx is dt over dx dt. So this is the speed. We just simply make a ratio. Here you go. Then dy dx is given by this ratio of the speed. Easy. So integrating this is easy. You move this to dy, dx, you move here. So the v over kx plus c, and y is ay minus y squared. Okay, so c is 0 when x and y are 0. So we get y equals fx here. Now it's rather x equals fy, say gy. Let's calculate how much it's moved. The stream moved the boat, right? So when y is a, you plug in, x becomes this. So the boat is moved by this amount when it's cross. Okay, I hope you enjoyed listening this, and please check out the video. If you like, click subscribe.